Hello, welcome back. Today I will solve LeetCode 1475, final prices with a special discount in the shop. We're given a list of prices for items in the shop. This list is in the form of prices array, such that prices sub I is the price for the ith item. It is possible to get discount for each item. The next item you buy that's cheaper than the current one. The price for that item is the amount that can be subtracted from the price of the current one. Let's walk through an example together. Take this prices array. The first item is $8. So how do we calculate the discount for that item? Well, we take the next cheaper item that you will buy, and we find the next one you buy is $4. So $4 is subtracted from the $8 of the current item, and you get $4. That's the final price for the first item. Next item is $4. So we look at the future purchase. We find that the next item that you will buy that is cheaper than $4 is $2. So $2 is subtracted from $4, and the price for the current item is $2. The next item is $6. You can see that the next cheaper purchase is $2. So 6 minus 2 is $4. That is the final price for this item. The next item is $2, and for the remaining of the purchase, there's no cheaper item that costs less than $2. So there is no discount for this item. Final price is $2. Same thing for the last item. Because that is the last item, so there is no discount because there's no further purchase. Final price is $3. Immediately, we can recognize the question is asking for the nearest smaller elements on the right. In the last video, in part 1 of this series, we talk about finding the smaller elements on the left. And we also discussed how we can modify that template to adapt for other purposes. Here, we are looking for the small elements on the right. So all we have to do is that we use a monotonic stack, and we build the stack starting from the last element to the first element. Now, if you have not watched my first video on monotonic stack, please go there and watch that video first. In that video, I explain how everything works. The link of that video is in the description below. This is the template that we adapt from the previous video. There's several things I want to highlight. Number one is that when we look at the question carefully, we're looking for the minimum index that j is greater than I, so the future purchase, and then the price of j is less or equal to price of I. We are looking for the price that are lower or the same. So we're going to make a monotonic stack that is non-decreasing. That is why this part of the code will pop the stack if the top element in the stack is greater than num sub I. Now using the pseudocode, let's populate the results array with this example. We are building the stack from right to left. So the top of the stack will be on the left side. We are iterating the prices array from right to left. The first item is number 3. The stack is empty, so we put the results sub I as 3, and we put the 3 onto the stack. The next item is 2. The top element on the stack is greater than 2. We have to pop the stack. Remember, we're building a non-decreasing stack. We pop 3, and then the results of I, because now the stack is empty, it is 2. We don't have a discount. And we put the 2 on the stack. The next item is 6. And 6 is bigger than the top of the stack, which is 2. And so we are good. So we do have a discount. And the discount is the top of the stack, which is 2. So 6 minus 2, we get 4. And we put 6 on the stack. The next item is 4. And 4 is smaller than the top of the stack, which is 6. So we have to pop item on the stack until the top of the stack is smaller than 4. We pop 6, now 2 is smaller than 4, so we are good. The discount here will be 2, and we do a 4 minus 2, that gives us 2 as the result of I. We'll put the 4 on the stack. The next item is 8, and 8 is bigger than 4, so we are good. We do have a discount. So 8 minus 4, and then we have 4 here as results of I, and then we put the 8 on the stack, and then we are done. Now we just convert this pseudocode to real code. This C# code is provided in the GitHub links below. Before we test this code, I want to talk about the time complexity. As discussed in the first video, the monotonic stack, every item is put in the stack exactly once, and they will remove at most once. So the runtime is O of n. Now let's take a look if this works. And it looks good. Next time we'll solve another monotonic stack problem. Hope to see you there.